Now we are going to compute demonstration of computation of lower limit and upper limit using with an example that we used previously from the practice computation. So in the case, we already computed standard deviation to be 1.71. This is the population standard deviation estimated based on the samples. Okay, and then the mean to be 3.5, because we already know the sum of the x, that's the sample, is 35 and sample size was 10, so therefore the sample mean was 3.5. So this means given standard error of the mean is computed by standard deviation divided by square root of n. 1.71 divided by square root of 10 equal 10. Square root of 10 is 3.16, so 1.71 divided by 3.16 equal 0.154, 0.54. That's your standard error. Okay, the lower limit and upper limit, in order to compute that, what you need to do is you're going to use the formula of mean minus z-score, confidence interval, multiplying standard error. In upper limit is mean plus z confidence multiplying standard error. So when you do this, mean is 3.5. Okay, z-score corresponding to 95% is 1.96. So it's going to be 1.96 and your standard error is 0.54. Okay, so this is all you need to do. Okay, so 1.96 times 0.54 equal 1.06. So inside this is 1.06. So the lower limit equal 3.5 minus 1.06. Upper limit equal 3.5 plus 1.06. So this means 3.5 plus 1.06 equal 4.56. Upper limit, that's 4.56. The lower limit is 3.5 minus 1.06 equal 2.44. Okay, and so that's what happens. These numbers are slightly different from the number 2 in the answer key for the practice computation here. The reason why it's different is, look at this. Here we use the population standard deviation of 1.8. Here we use the population standard deviation of 1.71. That's why it's different. But that's okay because it's a different numbers. So in order, I'm going to give a little bit more explanation of how this formula for computing lower limit and upper limit makes sense. So if you want to stick to just memorizing the formula of lower limit and upper limit, please do not pay attention to the following part of the demo. But if you want to understand why this works, please pay attention to that. So okay, so we're gonna talk about the percentage and z-score and rho score. There are 3 levels. In terms of percentage in the normal distribution, 95% confidence interval means 47.5% in each. Right? This corresponds to z-score of 1.96 plus and negative 1.96. And by the way, this assumes that there is somewhere around here is z-score of plus 1. This is somewhere around here is z-score of minus 1. Okay? And we know this is the z-score of 0. That's the mean. We also know the mean of the raw score is 3.5. This is 3.5. Okay? We also know 0.54 is a standard error. And this is basically the same as 1z. So that's going to be 0.54. Okay? So this is the 0.54. This is adding 0.54. So that means this distance is 0.54. This distance is 0.54. Okay? So in order to get to this and that, this is the lower limit and upper limit corresponding to 95% confidence interval. What you need to figure out is this distance and that distance. That's basically 1.96 times 0.54. Therefore, that's how we did in here. And that happened to be 1.06. So this distance is 1.06 to the negative direction. This is 1.06 to the positive direction. That's why adding 1.06 to 3.5 becomes the upper limit of 4.56. And then subtracting 1.06 from 3.5, which is 2.44, becomes the lower limit. Okay? Thank you.